Let's simplify the same radical expression here with two different methods, right? So here we go with the first method. So square root of 18 times a to the fifth power times b to the sixth power times c to the third power. So what's really happening here? So for this one, because that's a square root, we can put 2 here because that's the index, right? So the index is 2. It's actually invisible, but we put it in this case, all right? So now it's all about, what we're trying to do is all about breaking down each of these into a perfect square and then a non-perfect square. That's what we're trying to do, okay? So in that case, 18 can be broken down as what? 2 times 9, because 2 is not a perfect square, but 9 is a perfect square, right? So let's go for it. So that'll be 2 times 9. How about a power 5? For a power 5, we can rewrite it as a power 4 times a power 1. Because remember, when you multiply the same variables, you add the powers. 4 plus 1, that will give you 5. Okay? And then a to the 4th is a perfect square. Why? Because 4 can divide 2 twice, evenly. How about b to the 6th power? So b to the 6th power is then a perfect square. Why? Because 6 can divide 2 3 times. So that one, we keep it as that. Okay, how about c to the 3rd power? We're going to break it down as c2 times c1. Why? Because c2 times c1 is c3 when you add the powers. And then c2 is the perfect square. Why? Because 2 can divide 2 also evenly. Okay, so then we bring back the radical. So this one is a perfect square, this one is a perfect square, this one is a perfect square, this one is a perfect square. So all the perfect squares will go outside. Square root of 9 is 3, it goes out. Square root of a to the 4th power, remember we said there's an invisible 2 here. 4 divided by 2 is 2. So that gives you a to the 2nd power. Then b6, 6 divided by 2 is 3, so it's b3 out. Then for c2, 2 divided by 2 is 1, so it's c1 outside as well. So anything that is not a perfect square, we stay under. That means what? 2 is not a perfect square, it stays under. A1 stays under, C1 stays under. So we go, and then we say 3, a to the 2nd, b to the 3rd, then c, square root of what? 2ac. Ladies and gentlemen, we are now finished with this one. Okay, so that's first method here. Second method, let's go for it. For the 18, no problem. We're going to deal with it the same way as we dealt with this one. That will become 2 times 9, of course. Now, when it comes to the variables, a to the 5th power, we know that 2 can go into 5 twice with a remainder 1. What does that mean? That means if you were to divide 2 into 5, it goes twice. 2 by 2, 4. Subtract it. That gives you 1, correct? So that's the same thing we're going to have to do here. So that means what? So that means what we're going to have is then a is going to then be a to the 2nd power out, because 2 goes into 5 twice. So a2 goes outside. And then a1 is going to be the remainder that will stay under the radical. Are you with me? How about b to the 6th power? 2 goes into 6 3 times, so it's b3, no remainder. So we're not going to have b under the radical anymore. Let's go for c. 2 goes into 3 1 time, so that's c1, and the remainder is 1, so that we stay under the radical. So now we come back here, and anything that is not perfect square, we go under. But for now, remember, 18 is 2 times 9. So I'm just bringing that one down. And then for a, it's going to be a power 1, okay, because that was the remainder for that one. For b power 6, there was no remainder, so there's no b in here. For c, there's also a remainder, which is 1, right? So that would give us what? So that would give us c1 underneath here, okay? So then anything also that is left for the number, so that means square root of now, which is 3. 3 goes out, a2, b3, c. Square root, then you have a, so 2 first, a and c. ladies and gentlemen, you are finished with this one as well. Here is it. Same answers, different methods. All right? Thank you.